Hi everyone, welcome to EMQ webinar. I'm so happy to have you all. Today we are going to talk about choosing the most suitable MQTT brokers for your IoT projects. As you know, MQTT or Message Queue Telemetry Transfer Protocol is the standard protocol in the IoT world today, but there are multiple brokers in different languages. In this webinar, we will share some tips and factors that need to be considered when selecting MQTT brokers. And at the end of the webinar, we will have a casual talk part where we could discuss anything about MQTT brokers. Today, our speaker is Jelin, who is EMQ R&D Director. He has been working on IoT edge computing and completed the development and operation of the first edge computing and distributed charge pile system and private cloud. And before we kick off the webinar, I would like you all to know that we will be recording this session and all participants will be on mute by default. If you have any questions during this webinar, please type them in the Q&A box or raise your hand. After permission, you could talk with speaker directly and the questions in the Q&A box will be answered at the end of the webinar. We will share the recording of the webinar and slides in the follow-up email. So welcome, Jelin.
Hello, everyone. I am Jelin. So I'm the R&D Director and Solution VP from EMQX. But I would rather call myself an IoT explorer, just like you. Yeah, I once built and maintained a distributed charging network for electronic vehicles, which contains more than 40,000 nodes all around Asia. So in my project, one of my favorite and most commonly used IoT protocol is MQTT. And this is also the topic today I want to share with you. So I assume most of our audience today is already familiar with MQTT before. I won't go through the details of the specification, but just to review some basic knowledge of MQTT. So MQTT is a binary publish-subscribe messaging protocol working on TCP/IP stack. It is standardized by the OASIS Foundation. The most well-known characteristic of MQTT is it is lightweight, open, simple, asynchronous, and easy to implement. And here I also wanted to share some key findings from the Eclipse. So MQTT is already the de facto standard protocol for machine-to-machine communication and IoT market. As you can see from the chart, MQTT has emerged as the leading choice for IoT developers in 2021. So an MQTT broker is essential for your MQTT solution. And it is not strange to find out that 44% of people pick broker as their most commonly used technology. So therefore, this leads to our primary topic today, leveraging MQTT broker for your IoT project. Yeah, there are a lot of MQTT brokers implementations out there. It could be tricky to choose the correct one to start, especially for beginners. Instead of comparing which one is better, I recommend 8 major perspectives for you to need to consider when leveraging MQTT brokers. Also, I will try my best to walk you through those professional norms about evaluating brokers and give you a straightforward explanation. Before we start, let's be clear that some perspectives, like running on a cross-platform and being edge-driven and alarm triggering, are excluded because they are the fundamental feature of a broker. So here are the 8 perspectives. Let's go through them one by one. So first one is MQTT protocol compliance. So it is necessary to check if the broker implemented the full scale of MQTT specification. For the first one is protocol compliance. As an absolute minimum requirement. So MQTT 3.1 is a must. Usually the brokers here, they all claim and support the MQTT protocols, but you need to pay attention to some details features like QoS levels, return and last will message, and wildcard topics, and session persistence. Some brokers simply do not have it. But you may want to make use of them in your applications. Like QS here, it is important when you need to assure the message delivery or the session persistence to retransmit a message while the client disconnects and reconnects. And another important thing to check is whether the broker supports the newest specification, MQTT 5. MQTT 5 has a set of powerful features which could give you big advantages on architecture design, such as here shared subscription and topic alias and user property. But not all brokers fully support them. However, these features can give you tons of convenience, like shared subscription here. It is an embedded load balancer which can make your client-side work easier and increase your consumption power. The second one is open source. So open source software is eating the world. An open source broker can give you complete control of your service. There are many other reasons why you might consider using open source software, such as it is free to use and high adaptability and its freedom to distribute. These are 5 advantages for you. But keep it in mind, there are already some competent open source MQTT broker on the market, like EMQX, NanoMQ, FMQ, Mosquito here. You can just pick one to start your project. But while enjoying the convenience of the open source broker, but do not forget to have an in-depth review of the broker's liability, activity, and longevity. Liability is usually refers to license chosen by the project. There are couples of different licenses like MIT, Apache, and so on. And it is entirely, if it is entirely free for commercial usage or second-hand development, does all the code open up to public like this? And it's also really important to check who or what company is behind this project. And a successful open source project usually have a large community that you can get free support from. And the project itself benefits from the community's feedback too. But how big is the community? And are those developers willing to provide their support to you? Is this project receiving sponsorship from the big firms? This also could affect the direction of the project, and it could affect you too. Last one is the longevity of this project. So it means the energy or the health status of the project you choose. Anyway, I believe me, you do not want to end up in choosing an obsoleted and archived project for your application. But fortunately, the GitHub has provided us some valuable metrics for you to evaluate them, like the stars, the number of contributors, the commit frequency, and the number of open issues. So I recommend you to pay attention on these metrics before you decide to go with which one and to utilize this open source project. Like here, you can see the GitHub page of the different project. EMQ here has the most GitHub star here. Now we have finished the essence of the project properties. So now we come to the broker itself. The first and the most important category is the performance. Performance always refers to 3 different perspectives: latency, throughput, and scalability. So let's go through them one by one. The latency is usually refers to the time elapsed between the time a message is generated at its source node and the time the message is delivered at its destination node. As for the throughput is usually used to measure just how much the data can be transferred from one point to another within a set of amount of time. The scalability of the broker means the ability to handling the growing numbers of clients while increasing the resource or the numbers of your instance. So the first important one is latency. You know, the message, the MQTT broker is responsible for sustaining millions, even billions of connections. And it is very key. The latency is the key parameters for you to decide to determine if this broker is a real time or not. So usually we got a animation here to help you understand more about and get a more deep concept of what latency is. So here on the left side, we got some devices are publishing messages to the MQTT broker. Then you can visualize this data on your own backend. The user controls this device back while publishing the message back to them. But suddenly the latency increase. Then the message will pile up on the MQTT broker here. Then the device cannot receive the controlling message normally as before. But with the messaging pile up and pile up more and more, then it causes message loss. Then performance of this broker degrades. Then finally, this could cause the whole broker fail. So the message latency is usually indicates how fast a broker can route your packets from publisher to subscriber, or how much time it passed. The people always also use the response time to describe latencies. Statistically, there are like a max, minimum, or 90% of the time consumed by the broker to respond to each pub/sub request. This reflects the message latency. So short latency are essential for many real-time applications like IoT or Internet of Vehicles, where live monitoring or alarm triggering is desired. But one more thing to be aware of when you compare the benchmark result of different brokers is that the latency is always related to the specific scenarios. So like the QoS level of your message, the payload size, and the throughput. Here it comes. Now let's talk about the scalability and throughput. When people evaluate how performant one broker is, throughput is the first metric standard they will address. Throughput is a commonly known perspective. It measures how much data or messages can be transferred from one point to another within a set amount of time. It is essential for IoT applications if you need to manage all connections and messages in one space, like a unified namespace. You can measure it by different metrics like TPS or QPS. Basically, the TPS stands for transaction per second, and the QPS stands for query per second. As for the MQTT scenario, we mostly use TPS. But the TPS is also affected by the payload length of each packet and the concurrent connections. Therefore, we bring the concept concurrency into the story. Concurrency stands for how many MQTT connections a broker can handle at the same time. But we all want a high throughput. The scalability is the real reason behind it. When talking about scaling, there are two scaling options. The first is vertical. So it means we add more processing power or memory to your previous MQTT brokers. The second one is horizontal. So it means we add more nodes into your MQTT clusters. You know, TPS and QPS are used to describe how many messaging requests a broker can handle at a time. But how to calculate it remains diverged among the community. So I also prepared an animation here to explain to you how this concept works. For example, there are 5 cars here. They are publishing messaging to a topic with only one client subscribed in the rate of 1 message per second. But the broker only have 1 CPU core. And let's give a definition here. 1 CPU can only process 1 message per second. So all the messages have to be queued up. It means it is 2 transactions per second for host as a system. Now, let's imagine your business grows and being successful. We got more applications and have add one more car here. For scalable broker, we can try vertical scaling first. It means we add more CPU cores. Now you can see it can process 5 messages in and out at the same time. The transaction per second increase to 10. Or we can try horizontal scaling. So it means instead of adding the more CPUs here, we add more nodes into our MQTT clusters. We deploy clusters and the different nodes. With 5 nodes in a clusters, the EMQX clusters don't even sweat even if the throughput is up to 10 millions. In this way, it not only gives us more throughput, but also ensures the high availability of your MQTT clusters. Since we have mentioned about availability, so high availability is a classical question in computer science. In addition, there are some other well-known requirements like clustering and redundancy, and data isolation, and consistency among all nodes. So under the circumstance of IoT applications, when choosing an MQTT broker, you need to consider the following cases. So is your cluster, and the nodes in your clusters act as one integrated service and be transparent to your whole all other client. So this is auto discovery and auto join. So for your client, they do not need to understand there are nodes behind this load balancer. So the broker usually achieve this by using a load balancer such as HAProxy and NJAX. And when one node failed, can other nodes keep functioning and take over what is left? Then this is called failover. And could we reserve those messages already rerouted to the failure node when one node is done? So this is called data redundancy. Is there a potential risk of lost cached MQTT message if the client reconnects to a different node from the last time? Then it is called session takeover. This is useful when you need to catch messages while the client is frequently disconnects and reconnects. So, and the last one is replication. So the replication strategy always refers to the way you're doing the distribution consistency. So can this client get the same service when subscribing to a different clustering nodes? This is important when there are massive clients disconnects and reconnects at the same time. If the broker chooses the bad strategy for the replication, then the whole service could be brought down. The next one I wanted to emphasize is about interoperability. So this term also refers to customization and integration in some places. So after all, the MQTT broker is still only one part of your whole IoT architecture. So you need to examine if the broker is easy to integrate with other components of your system. So in other words, if an MQTT broker can provide like a rich RESTful API or pre-built connectors that can easily bridge message with other message queue, like commonly used Kafka or RabbitMQ, then it can make your work easier. Additionally, another commonly requested features is regarding to the integration is data persistence. So for your IoT applications, you always need to use different database like MySQL, InfluxDB, or TimescaleDB. If your broker is able to bridge data into other database without writing another line of code, that would be a big advantage for you. As for the customization, it might not work for all scenarios, but it is case by case. But when you want to extend some broker features or manipulate your messages on the MQTT level, especially when dealing with multiple kinds of encoding like protobuf, then a fully customizable MQTT broker is necessary. Like EMQX here, it can provide you a mature and performant plugins and a highly customizable rule engine that allows you to write your own business logic with it. And with your business growth, you may also encounter some other IoT protocols other than MQTTs, like COP, MQTT-SN, XMPP, because as we all know, the end device market are fragmented. Then the capability to support these protocols in one single broker and let them talk with each other is vital to achieve the seamless data convergence. So in a word, a highly integrable MQTT broker could significantly ease your burden, make your life easier. This is my experience. Okay, here comes the security. The security is always the one perspective neglected by a lot of customers. So the convenience is a double-edged blade. While you enjoy all the fantastic features of your MQTT broker, don't forget to keep your IoT data and connection safe. A broker's security is largely determined by the user configuration and only to a lesser extent by the broker's security features. So here are some four commonly need to consider the perspective regarding to the security. So the first one is the confidentiality. So it means the data is only accessible by authorized users. For example, MQTT itself provides your core feature like a username password to ensure only a logged users is allowed to connect to your broker. And there are some other authentication methods like JWT tokens and so on. And I wanted to emphasize to bring one important feature to you is ACL, or called accessibility control. So ACL provides you with a fine granularity of controlling on the topic that each client has access on. This is vital if a client is hacked and you wanted to prevent it from doing more damage to your system. And this case is common because when in your IoT application, you always distribute the devices, your hardware device to different customers, and sometimes it can be lost, and you cannot ensure all these devices is running in a safe place. The second one is integrity. So integrity is to protect the data against being modified either by accident or maliciously. So these techniques that ensure confidentiality will also protect the data integrity since the attacker cannot modify data without accessing it first. So there are some commonly used techniques like TLS, DTLS encryption, and some certificates can help you to ensure your connection is safe. The third one is availabilities. So it means while protecting your data from attackers accessing or modifying them, but we also need to ensure that it can be accessed by the legit users with proper permissions. So your MQTT broker is just like other microservices. They have their own open port to the public network, so and it could be DDoSed. And so in this case, the flow control features comes to your mind. With the flow control, you can ensure if your password and username is compromised, and your broker will not be brought down by the malicious actions. So you can control the message rate of each client and to prevent them to DDoS your brokers to a severe condition. So like okay. So the last one is also called interoperability here. So this means you can customize your authentication method with pre-built databases if there is any. So usually our customers use it to integrate with enterprise security solutions. If they got like LDAP servers, or they can store their own password and username in their own database. Okay, so there are 8 major perspectives I wanted to share with you. Of course, there are some other perspective like resource consumptions and operating system you need to run on, and how much memory and CPU processing power you could provide. This also can come as metrics, but I just wanted to ensure these eight perspectives can help you to leverage your MQTT brokers, and when there are a lot of open source projects on the market. So here are here are a spoiler of our next webinar. So it's about MQTT broker cluster scalabilities. So we're gonna do a quick introduction to the Erlang and the Erlang machine and the OTP, and to do a cool demonstration about how scalable EMQ is, and to demonstrate with our own benchmarking tools called EMQTT Bench. You can see the whole broker can reach 100,000 connection concurrency in live show. So just feel free to drop a visit at April 6th, and you can scan the code here and to register with your own convenience. Okay, thank you. So don't forget to start us on GitHub. If you have any questions, you can connect me with on the LinkedIn or join us on the Discord or Slack server.